Students usually struggle here understanding whether this is a minus sign and then this is positive 2, or this is a negative 2. Okay, the answer to this question is this is a negative 2. You can rewrite this problem as negative 1 and negative 2, which is the same as negative 1 plus negative 2. So now you see that this is a negative. Okay, that said, so we need one red chip here and two red chips over here. So basically we're doing one negative and two red chips and two negatives. So this is what we end up with. We don't have any white chips to take care of the to take out the red chips, so we end up with negative 3. All right, so we start off, we have negative 6, so we need 6 red chips. We start there, 6 red chips for negative 6. Now, we have a problem here. This is something new. Initially here we had one minus sign and we said this is the same as plus negative 2, but now we have 2 negative signs next to each other. This is when chips get flipped. So normally we were supposed to have 2, if this was a negative 2, then we needed 2 more red chips for this negative 2. But this minus sign in front of this negative 2, this minus sign flips the chips so that we now have, it flips it to white and flips this one to white. Okay, so basically that is saying that this problem can be written as negative 6 plus 2 because this double negative flips the chips. Okay, that said, now we have positive 2 and negative 6. So these, we understand the rule, these are getting out because a red and a white, they get out. And so this is what is left, negative 4. Negative 4 is the answer. Okay, number 5. Let's look at as many possible problems that you could see with integers. Now let's try 1 minus negative 6. All right. You must be getting ready to flip some chips because there is a double negative here. So let's start off with one white chip because this one here is positive. Now we were getting ready to put negative 6, we were getting ready to put 6 red, but this other negative flips them to white. So it's going to be now 6 white chips. 6 white chips over here. Okay, so that is it. Why do we not have red chips on this side for negative 6? Because this other negative here flips the chips. Okay, so double negative flips the chips. So that said, now this is our answer right here. We don't have any red chip to go out with a white chip. We take it out, and therefore we have 2, 4, 6, 7. Positive 7. 7 positive white chips. Okay. By this time, you should be able to notice or build a rule to tell you that in an integer problem, you can tell if there are more negatives or more positives. So we are not going to use chips for number 10. We see negative 50 and we see positive 20. Now this tells us that if we were putting out chips, then negative 50 means we have 50 red chips. That's a lot of them. Now, with these negative 50 red chips, they have enough chips to take out the positive 20 chips. So bottom line, you will have negative 50 of them, and then you will cut 20 red chips to take out your 20 white chips. Then you will have 30 red chips that have not been taken out. So in the problem like this, you'll notice that you will have an abundance of negative chips, but then how much will be left? It is the difference between 50 and 20, which is 30. Okay, so from number 10, you can build a rule that you can use to solve integer problems without using the chips. The chips help you to build the concept, but you will have to graduate from using the chips. Okay, thank you.